right, good morning, good afternoon, good evening, and welcome. So this is our first lesson in chapter 9. This video will be split into two pieces. When you get the notes on Canvas, ladies and gentlemen, you will get all of the notes, but we'll only go through half of them today during this video lesson. This will be the process as we go forward this year, the remainder of the year, as we cover in quadratics. It's a lot of information in a short, condensed amount of time each and every time that we watch these videos. We'll be using a lot of math that we've been covering over the last couple of months and years with solving simple equations and then factoring and doing using properties of square roots like we were using prior to break. And then after this, ladies and gentlemen, we will show you how to use Desmos with solving some of these and going forward. It'll be just a whole smorgasbord of new information. Dealing with quadratics is going to be a very important topic for you guys because it's a very big topic of conversation as you move into geometry and as you go farther on in Algebra 2 and beyond. So it's very important that we cover this material with you guys and that you're with us along on this journey. Even though we may not see you on a daily basis, ladies and gentlemen, know that we are here to help you out, and we're going to give you as much and as many resources as possible to make sure that you do succeed, not just for this year, but for the years to come. All right, and let's get started. So this is called graphing quadratic function, but we're going to be hand graphing. We're not using Desmos or anything like that because we're going to be analyzing the characteristics of the graphs of a quadratic function. We will be doing a little bit of graphing on it, but not too many. There are some vocabulary terms we're going to be covering as we go through this. Some of these you've seen before, some not. Here's the big key thing on your notes, okay, is that there is a parent function called x squared. If you were to go onto a graphing calculator and type in x squared, ladies and gentlemen, it would be a perfect parabola. That's what this is. That's the type of graph. A parabola that comes down, hits 0, 0, or the origin, and goes back up. It's perfect on each side. Parabola is going to be one of those things where as we move forward, it's going to be a big major issue with you guys to make sure you understand the different concepts and realities that come along with it. There is standard form. We've talked about this already. Ax squared plus bx. We've been hammering that over even before break we did. Type of graph is parabola, axis of symmetry. This is a big formula we're going to be using this year for the remainder of the year to try to find the axis of symmetry. Now, the axis of symmetry is pretty simple. If you guys remember growing up and you made either paper airplanes, where you would fold the paper in half perfectly, or like snowflakes, if you guys grew up in crafts, where you take a piece of paper, you fold it over, and then you start cutting little pieces out here and there, you unfold it, and it's the same on both sides. That's what an axis of symmetry is. What is unique about an axis of symmetry is when it runs down through here, it runs and cuts the line perfectly in half and creates what's called the vertex, which is a point where the graph stops. So remember, you read graphs left to right. So even though this arrow is going this way, technically this arrow is coming down, the graph stops here. So that's the minimum point. We will learn about that as well. This is the vertex, it's the same thing, and then it shoots back up, okay? And so we're gonna know a lot about this little point. We're gonna talk a lot about it today as we go forward. And then there's also the y-intercept, which is just the c value, which is this value right here. So it's a pretty simple concept for you guys to understand. All right, so let's get started. We're gonna identify, using this table, we're gonna state the axis of symmetry, the y-intercept, the domain, and range. So for my benefit, I need to write the formula down again. It is going to be x equals, and it's negative b over 2a. Right? You guys have that on your notes. I have to do it just for myself. A, b, and c. You have enough room on your notes to write these down. Remember, it's ax squared plus bx plus c. So please make sure you identify the a values again. This is a 1, a -1, and a -2. Okay? Those are our values. This helps do these formulas and everything else with a relative ease. All right, axis of symmetry is first. So the axis is going to be x equals, and when we say x equals, if you were to graph x equals whatever number, it's going to be a straight vertical line. That's what we're looking for. Okay, so the formula is x equals a negative, and then it's going to be b. So our b value is -1. And then it's 2 times a, which is 1. All right, so we know that negative times a negative creates a positive, so that this actually is 1/2. So what this means is at 1/2, there would be a vertical line. So on your notes here, put a little vertical line as best you can at 1/2. Not too bad. Mine's a little crooked, but it doesn't matter. You guys get the gist, right? So we know there's a vertical line at 1/2. We know the vertex is along this line. We know the graph is going to come down and stop at some area on this graph, but we know the bottom point is going to be on the line of the vertex. All right, what is the y-intercept? The y-intercept is the c value, okay? So the y-intercept equals -2. So we know if it's -2 at this point, ladies and gentlemen, you can take on your notes, let's make it, where's my green? -2, 1, 2, you have a dot, there's your y-intercept, right? And then we also know that, what is the domain? So the domain of this function is always all real numbers. 95% of everything that we do, I would say the domain is all real numbers. The only time it's not going to be all real numbers is when we get later on in math, okay? When you guys get to algebra 2 and you start taking this parabola, you know, the graph that comes down like a U or like a hill, and you take it and you turn it sideways to make it look like a Pac-Man or a letter C. That's the only time the domain is going to change. We're not doing that. I don't even know if you do that until you get to pre-calculus. So for right now, as it stands, domain is all real numbers because it's going from infinity and beyond from left to right, okay? So make sure you guys know domain is all real numbers. So when in doubt, pick all real numbers for domain. The range, however, is vertically speaking, okay? So here's the problem we have. We know that the x value is going to be, we know the vertex is somewhere on this line. So we know the x value, which means going over, is going to be 1/2, right? So we know our vertex is going to be 1/2, but we don't know what y is. So what you're going to do is put this back into the original equation, right? So on this then, we'll fill this in. It's going to be y equals, and then it's going to be 1/2 squared, and then it's going to be minus 1/2, and then minus 2, right? So I just took what we learned right here, 1/2, and I just plugged it into this value. Okay, that's all I've done. Okay, now as you move forward, you kind of just do simple addition. So if you have a negative and a negative, and you're adding them together or putting them together, it's -2 and a -1/2 is going to be -2.5. Oh, don't start this. -2.5. Okay, and then if you don't know what this is, you can put it in a calculator, right? It's 1/2 times 1/2, which actually comes out to be 1/4. Oh, my pen's starting to stick. Hold on a second. Hey. Yes, that was weird. All right, so you guys, this is going to be 1/4, and it's going to be y equals, right? Because that's what 1/2 squared is. Now, what is a positive 1/4 minus 1/2? Well, it actually comes out to be y equals 2 1/4. Right, so we know that if I were to go on this graph here, that if I were to plot out a point, we're using green, that I go 1/2 over, and then it's going to be 2 1/4, so it's somewhere right around there, right? So we know that's the point. Now, if y equals 2 1/4, that means this graph is going to come down, and we'll plot out these points in a second, and you'll see it. Then we know that this range is going to have to go to a certain area. So, like for example, if we start plotting these out, I go 1, 2, -2, 4, -1, 0, and then 0, -2, we've already got that one. Then 1 over -2, there's another one right there, 2, 0, so it would be 2 over 0 up. And then the last one is 3 over 4 up. So you guys can see, then if I were to take a line and try to connect the dots, and this is a good try because, yay, that was close. There's the connection. You guys can see kind of how it works. But what is the range? Okay, so the range means, remember, imaginary line that's right here, this graph goes up. Okay, so we know at 2 1/4, you know 2 1/4 is the bottom, and we have a y value, but what are we eating? Okay, it's every value that's going to be what? Greater than 2 1/4. So that is your range. All right, so hopefully you guys understand that, and you guys get the concepts behind it. Make sure you fill in your notes, and go from there. All right, we'll do one more together. I'll go a little quicker on this one. A, B, C. All right, so it's 3, 6, and -4. All right, and then you guys do axis of symmetry. So axis equals, it's a negative, and then it's what? B is on top, All right, so b is on top, so that b is 6. And then it's 2 times your a value, which is 3. And so this would be 6 divided by 2 times 3 is 6. So that's a -1. Okay, so same thing again. We know we could plot right now a dotted line at -1. So if I go over here to -1, there's my axis of symmetry. I stuck it up at the bottom, but that's fine. Okay. Then your next piece is, what is your y-intercept? Well, the y-intercept is your c value. Remember, that's from before, so our y-intercept is -4. So I know on here I can go to -4 right away, go down to -4, 1, 2, 3, 4. And I got my intersection right there, sweet. Then what is my domain? My domain is always all real numbers. All real numbers. You can put R in if you want, just so you guys know what it is. Now my range, here's the tricky part again, right? So we know the x value is going to be at -1, right? We know the vertex is somewhere on -1. So now you're going to put -1 back into this formula. So let me expand this out a little bit here. Okay, so it's going to be y equals, all right, so we know it's going to be y equals, and then it's 3. And then we're going to put a little gap here, squared plus 6, and then we're going to put something in there, -4. And that's something, as we said earlier, is what? -1, -1. That's what x value is, because we want to know what the y is. We want to know where it's at on the vertex. You solve it. So -1 squared is a +1. So this is going to be y equals 3 minus 6, right? Because that's 6, and then -1 is going to be 6 minus 4. Okay, put those two together, that's -10 plus 3, -7. All right, so we know at this point, intersection down to -7 is our actual vertex. So if I were to graph this out, I go over 1, 2, 3, 4, 5, 6, 7. I know my vertex is right there. Okay, so know that, ladies and gentlemen, that's actually your bottom point. So what is your range for this function? The range of this is going to be, if I already have so here's one key thing for you guys to know. If you have a vertex here and a point above it, which way do you think this graph is going? Is this graph going to be going down? No, it's going to be going up. Matter of fact, if you want to graph the rest of the points, you can. 1 over 5 up. Okay, and then we got 0, -4, we've already got that. 1, -1, -7, -2, -4, and then we have -3, 5. 1, 2, 3, 5. All right, perfect symmetry there. And then you would connect the dots. All right, something like that. I can always do it better going back up. There's your graph. Now you have to ask yourself, what is the range? Same thing again. Here's your bottom line, and every point is going up with that. So you know that your y value and a -7 are your two things. But what is your actual answer on this one? You know that, once again, every y value going up is greater than -7. So that is your range. All right. Hopefully you guys understand this concept. Simple? All right, your turn. Now I want you to fill in this table. So it's simple enough though. Make the values of x. Let's go -2, -1, 0, 1, and 2. Ladies and gentlemen, put those into here. Get your y values. State your axis of symmetry, y-intercept, domain, range, and then we're going to graph it. All right, so these table values, make sure as you guys fill these in. Hopefully you guys did this on your own, you figured this out. It's not that hard, it's just good practice, right? So -2 squared would be a +4. So you would go, you would put a little bracket here, -2 squared plus 3 is 7. Whoop, I'll do that just so you can see it. All right, then this would be a -1 squared plus 3 would be a 4. Okay, then 0 plus 3 is 0 plus 3 is 3. And then you would have in here 1 squared, 4, and then you'd actually have the same thing where it'd be 7 again, right? So you guys can see a little pattern here. It goes 7, 4, 3, 4, 7. And as you guys actually keep going out, the -3 and the net 3 are going to be the same, and it's going to keep going out where these values will be the same going out because it's a parabola. It's supposed to be that way. If it's not, know that you plotted your points wrong. Okay, axis of symmetry, right? So our A value is 1, our B is actually 0, it doesn't exist. And our C value is a what? 3, okay? So that's what this value represents. Okay, so now you know your axis of symmetry is going to be negative, and if you guys have the formula, remember it's negative B over 2A. So if it's a negative B on here, this would be 0, and it'd be 2 times 1, and anything with a 0 in it, on the top especially, is a 0. So our axis of symmetry is actually at 0. So what that means, ladies and gentlemen, is you would draw a axis of symmetry or a dotted line right on the vertex, okay? Sorry that buckled out. I had it on there, but the smart board messed it up for me. Okay, so there's your axis of symmetry. Now you have to ask yourself, what is the vertex? Same thing as you go through. If this is a 0, okay, you plug this in. Or wait, let's do the y-intercept. Forgot. Y-intercept is 3. Right? So we know at 3 is the y-intercept. So 1, 2, 3 is the y-intercept. Okay, and then it says, what is the domain? The domain is all real numbers. Okay, and then what is my range? Now on this one, I'm going to graph it first. Sometimes if you can graph it and you can figure out what the bottom point is, you guys will be set for stone. Like for example, we know that this is going to be 0. That's our axis of symmetry. But we also already know our point for 0, which is 3. So we already have that. And then we got negative 1 is 4. And then we got negative 2 is 7. So it's going to be 1, 2, 3, 4, 5, 6, 7. All right, and then the other side is exactly the same. So you would mirror the points. Okay, that's one thing about doing these parabolas. Once you get used to this, you guys will see that the point on the left and the right are actually similar, especially if it goes through a 0 as the vertex. Okay, so what is my range? My range in this one is going to be 3 and y, and it's going to be every value that is what? Greater than 3. Simple enough. Hopefully you guys got that. All right, now we're going to move on a little bit, and I'm just going to give you a graph, and we have to figure out what the range, the domain, the axis of symmetry, and if there are any zeros of the function. Okay, so that's the new thing, zeros. What are the zeros? There are only 2 zeros that I care about, ladies and gentlemen, and it is where this graph crosses the x-axis. That is what a 0 means, okay? So what you guys need to understand is this is the y-intercept. Is there a 0 in it? Yes. Is that the 0 I care about? No. Okay? When it says zeros in a graph, it's talking about these 2 things. All right? So let's find the vertex. Vertex is where it comes down and hits. So the vertex is right there. All right? So my vert is 2 over 1, 2, 3, 4 down. Simple enough, right? Remember, this is about identifying characteristics from graphs, okay? What are my, the next thing is, what is my axis equation of the axis of symmetry? Well, technically speaking, you don't have to write that equation. You guys should know that there's an imaginary line that goes through here. So my axis is going to be x equals 2, right? If I go into Desmos or any graphic calculator and I put x equals 2 on a graphic calculator and hit enter, it'll give you a vertical line straight through 2. All right, then it asks for what is the y-intercept. Okay, the y-intercept in this case is going to be 0, 0. And then it says, what are the zeros of the graph? It just so happens, ladies and gentlemen, that this y-intercept and the zeros are the same on this graph. Okay, so this one, the graph is 0, 0. Because that's where it crosses the x, is at 0. But it's also at 4 over and 0 as well. That's the other 0 point, right? Okay, so let's look at this one again. Let's look at the next one. There's the y-intercept right here. There's the vertex, right? So the first thing we need to find is the vert. The vertex is at this point. So this is 1 over. And it's 1, 2, 3, 4, 5, 6, 7, 8, 9 up. Okay, and then your next thing is, what is the axis of symmetry? Right? We know the axis will run through the vertex. If it runs through the vertex, it is x equals 1. And then the next piece of the puzzle is, what is your y-intercept? All right, your y-intercept here is where the graph crosses at y. which is going to be 1, 2, 3, 4, 5, 6, 7, 8. Your y-intercept is just the number 8, okay? Realize that. It's where it crosses. I'm not asking for the point. I want just the number 8. And then if Alex asks you for a point, then it would be what? 0, 8. You guys should be able to figure that out. Zeros. Zeroth functions are where they cross the x only. 1, 2. So that'd be negative 2 over 0 up. And then this is 1, 2, 3, 4. 4 over 0 up, right? Okay, the next functionality here. What is the vertex? All right, vertex is right here. It is at 1, 1. 1 over 1 up. Axis of symmetry is at x equals 1, right? Because I can draw an imaginary line right through the middle right here, and it goes through the vertex. Y-intercept. All right, y-intercept is 1, 2, 3, 4. All right, so my y-intercept is 4. Now it says, what are my zeros? Okay, this, ladies and gentlemen, does this graph have any zeros? The answer actually is what? No. So what this is that means there are no real solutions. It's very important for you guys to understand that when it says what are the zeros, and if the graph never touches the line, it's no real solutions because you don't have any zeros, right? Okay. Use these to answer these. Give me those 4 pieces. All right, vertex, equations, all that good stuff, right? So we got vert, axis, y-intercept, and zeros. Okay, so what we have here, remember vertex is going to be what? 1 over, 1, 2, 3, 4 up. My axis of symmetry is x equals 1. My y-intercept is at 3. And my zeros are negative 1, 0. And they're at what? 1, 2, 3, 0. Okay, this one here, your vertex is going to be at 1, 2, 3. So your vertex is 1, 3. All right, your axis of symmetry would be right here, and is x equals 1. And then what are my y-intercept is 1, 2, 3, 4. That is a y-intercept is 4. Now I'm writing it up here to make it easier for myself. You guys write it down here. And then the zeros are in fact what? No real solutions. Okay, the last thing here. So this is going to be same thing, right? We got vertex is going to be negative 2, negative 1. Okay, and then you're looking for your axis of symmetry. Your axis of symmetry is going to be x equals negative 2. And then what is your y-intercept? Your y-intercept is going to be at 1, 2, 3. And then the last piece here is your zeros. Okay, your zeros are going to be at negative 1, 0 and at negative 3, 0. Right, and then you go from there, and that's it. So hopefully you guys got those pieces on your own, right? All right, so one key thing is we are going to, let me look at my notes here real quick. We're going to stop at this point right here. I think we'll be able to cover it up a little bit more as we go through. We're going to identify characteristics from functions next, which is a little bit more difficult. So please stay tuned, and we'll make sure we get you guys properly set up. Check the Alex homework. We should be able to start to do some of these things as we go through the process today. If not, we'll have the other videos set up for you really quickly, and then you guys will be able to continue on the homework. All right? If you have any questions, please email or chat up with your teacher when they have office hours. Good luck, everybody.